All right, let's get started on part 5 here, or rather test 5, part 4. So if you missed the first 3 parts, make sure to jump back. Some of my favorite problems are on this test. Where I'm grabbing this from is right here, HubSpot test 5. I did the previous 4, and we're going to be doing the other 4 after this. So let's start with this one. This is a really good geometry problem. I'm looking at this, and again, I already want to create my inclinations. What kind of habits have I created that when I see this, I have an idea of where to get started? So there are going to be 3 things about this shape. 2 that I think we should be able to derive either now or in the near future. The third one is going to be one that most people don't know, which I would probably just make a note card. But we'll get to the third one. Let's look at the 2 that we either do know, have seen before, or will know in the near future. So is there, and again, if you want to try this on your own, go ahead and pause it. What type of shape do I see here? A lot of times I say, try to create triangles. So maybe I can kind of like try to see if I can make a triangle. I don't think I see any triangles. Are there any sort of right triangles? Because look, they already have my center to all my endpoints. I mean, making another line like this, I don't really think that's going to help. There's no right triangles that I can make in this shape. That's going to be important to distinguish between the ones that you can make right triangles. I just have no kind of direction to really make right triangles here, but I do see things that I could know. How many sides is this shape we have here? I see 1, 2, 3, and 4, right? 4-sided shape, we should be able to get 360 here, right? So 360 is equal to, I see an angle A, I see an angle P, I see 20 plus 20, so I'm just going to say plus 40. And where I'm getting these angles from, so just like a square where we're going to have those 4 angles that add up to 90, I have 1 angle, 2 angles, 3, and 4. This has to add up to 360. Any 4-sided object is going to have 360 degrees inside. So this is one equation I think we could derive now or in the near future. I think this one is manageable. The second equation, I almost highlighted already. Look at this equation right here. This is just going to be our circle. Anytime we can draw a circle around an angle, that's going to equal 360. So I could say P plus X equals 360. So already I could simplify my equations. I could just say P plus X is equal to A plus P plus 40. And then I could start to simplify again, or subtract both sides by P. And look, I'm already getting a nice little equation. X is going to be equal to A plus 40. Let's use a different color there for that A across that line. For A. Okay. So I still have 2 variables for one equation. I can't solve for this yet. Here's where the tricky one comes in. Here's where I'd probably make a note card. I mean, I'd make a note card of as many things as I possibly could. This one in particular, I want to highlight angle A and angle X. And I just want to ask if you knew there was a relationship between these 2 here. And you had to guess. It's a very direct relationship. I'm not talking like square root 2 relationship. Very direct. Multiple or fraction. What would you guess? If I told you X was 100, what would you guess A is? And it is going to be a pretty memorable relationship. X is going to be twice as much as A. So it's a role. We don't see it very often, so it's harder to reinforce and memorize. So I would say A is equal to 1/2 X. Just a role. This one can really trick people up because there's not really like a way to solve it or proof for it. It's just kind of something you have to memorize. So once I know that, I can just replace A, right? I can say X is equal to 1/2 X plus 40. Subtract X from both sides. Let me use a different color here. I should get 1/2 X is equal to 40, or multiply both sides by 2. X is equal to 40. X is equal to 80, sorry. But yeah, not too bad of a problem. I feel like the first 2 equations that we did are manageable. I think that they could be mastered in a week or two. Quadrilaterals, circles, right? The third equation, again, as niche as it is, as many times as we don't see it, make a note card of it. I don't think it's that bad. With these three equations, we can solve for the shape. X is equal to 80. So decent, very, very good geometry problem. Down below here, oh man. So there is a lot of context here. Okay. So let's just get started. So I have segments of a drive. So I'm going to be a little bit more outlining here than I normally would be when I'm taking the test, just so everyone can get like a really good idea. So from home to freeway entrance. So I could say something maybe like home, and then maybe freeway entrance. And then we have from freeway entrance to freeway exit. So maybe I say like freeway exit. And then at the very end, freeway exit to workplace. So as you can see, there's 4 points, but we have 3 segments. And then I look at them, it's very lopsided. So from home, we live very close to the freeway. This is only going to be 0.6 miles. 0.6. This guy's going to be most of the journey, 15.4. And then this one down here is just going to be 1.4. And we're driving at different speeds for all of them. Oh, okay. Let's see. Table shows in distance in miles her average driving speed in miles per hour when there is no traffic delay for each segment of her drive. Okay. Not too much more to absorb from the table. I think we just got to start with number 37 here. So let's try to highlight this. So 37. Let's see what they want. They say drove directly from her home to her workplace in 24 minutes. From her home to her workplace. That's the full drive. So before I even read the next line, I'm already thinking, okay, so drove the full distance from home to workplace. That's going to be what? 17.4 miles. Okay. In 24 minutes. So I could just label that here, 24 minutes. Okay, so we have a speed, we have a, we have a distance, we have a time. What was our average speed in miles per hour? So they help us there just in case phrases like that confused us. Average speed, they say they want miles per hour. So if I just, did it as it is right now, I would get miles per minute. So this is going to be a really good example of how to convert units. You might have already mastered this already, but this is a way where you can't mess up. This is a way I would start using now and practice and use in your other classes. So what you do is it's always going to turn into this kind of like segmented fraction system. So I make this new segment. This is going to be a translator segment. And this should always equal 1. Because I can't change the actual numerical value of my fraction, right? If they're going 20 miles an hour, it has to say 20 miles per hour. So this has to equal 1, what I put in here. So what unit do I want? So there has to be hours in here. And then I ask, do I want hours in the numerator? Or do I want hours in the denominator? And of course, we want miles per hour. We want hours down below. So I keep hours down there, and I say, what's a good unit for hours? 1. We would want a distance or an amount of miles per 1 hour, right? And then I say, okay, what's going to cancel out with 1 hour? And we already have minutes, so couldn't I just say 60 minutes? Is this not equal to 1? 60 minutes divided by 1 hour would equal 1. And then there's a second way to view this problem. So not only do I want this to equal 1, I need this to be one big fraction. So what units do I see here that could cancel out? Well, I only see 1 miles. I see 1 hour, but I see minutes on the numerator and minutes in the denominator. Minutes goes away. The only units remaining are miles in my numerator and hours in my denominator. So I just do some quick math here. All the numbers are in place. 17.4 times 60 divided by 24. And look at that. 43.5. Let me erase that real quick. 43.5. And my units are miles per hour. So if you're looking for more examples of this, I know there's another one coming up in the practice tests, but there's already a really good one. Jump back to one of my part 3s or part 4s, and you'll see it's like a Falcon speed problem, and it's a triple conversion. So we do 3 whole segments of converting, I think it was meters per feet into miles per hour. So something like that. It was meters per second to miles per hour. So a bunch of conversions we did there. It's a really good problem. But this was just the intro. 38 is going to be the more interesting one. Let's look at 38 here. Let's grab this guy and shift it just like that. Okay. I would like to include my table just a little bit just in case. All right, let's see what they could possibly ask for here. So starts her drive at 6:30 a.m. Okay. Could be a timeline problem. She can drive at her average speed with no traffic delay for each segment. So this is just going to be what's already in the table. So maybe they're going to make a comparison now. Let me get a different color. They say if she leaves at 7, okay, so you know, she beats traffic because she leaves a little earlier. So at 7 here, the travel time from the freeway entrance to the freeway exit. Okay, so it looks like they're highlighting this segment right here, and I'll scroll up a little bit so you can see it better. So only that segment is increased by 33%. So this is going to be 33%. And let me just get the unit real quick. The travel time. So the travel time is 33%. Okay. So let's shift that up. All right. But the travel time for each of the other 2 segments does not change. This is the same. This is the same. So that's not too bad. They're only comparing one segment, which makes it nicer for us. How many more minutes does it take Miss Simon to arrive to her workplace if she's leaving at 7, right? So I feel like there's a lot of ways we could go about this. There is kind of a way that I want to show because it's really good for practice with a certain type of problem. But let's just do the most efficient way to solve this problem now, and then we'll kind of show that as a lesson after. So these are the same in both. So I don't even have to look at those 2. Leaving at 6:30, leaving at 7 is going to be identical. The only difference is this. So 33% longer. Well, can't we just see how long it takes her right now? We just did an equation over there. So right now, she is driving 50 miles per, and I'll scroll down a little bit, 50 miles per 1 hour. Man, let me scroll up a little bit more. Okay, 50 miles per 1 hour. And she is traveling a total of 15.4 miles. So this is where it can get a little confusing. My miles is on top and my hours are on bottom. If you want your answer to be in time, let's flip that, right? I want it to say in 1 hour, and you'll kind of see a little bit more retroactively. In 1 hour, I can travel 50 miles, right? That is what our speed is saying. The reason why I'm putting hours in the numerator is because I want my result to be in time. So then I do my little translator here, and I think this is only going to be a 1-part translator because all we have is 15.4 miles. So look, if I put 15.4 miles, what would happen here? These 2 would cancel out, right? So right now, my final answer would be in hours. We don't want that, right? We want our final answer to be in minutes, so we could compare it to the 33% increase, right? So what I could do is my little translator, I could say 1 hour turns into what? In 1 hour, so I guess I have to almost go backwards here. So I could say in 1 hour, there's 60 minutes. Right? So this cancels out. And the only reason I didn't have a double over here is because I only have 1 unit. So my rate was 2 units. It was 1 hour per 50 miles. The 15.4 is just miles. What that helps me with is I'm not translating. That's just canceling out distance. So then I'm just left with time. So then doing it this way, I cancel out hours. And what's left? Just minutes for my units. So let's go ahead and throw this in here. 60 times 15.4 divided by 50. It looks like it takes 18.48 minutes, that little freeway travel. And then here's where it actually gets really easy. The increase is 33% in time. So all I actually have to do to answer this one is multiply this by, well, I guess you could do 1.33 if you wanted to know how much time it took her leaving at 7. So maybe we'll just do that for now. So 18.48 times 1.33, and we would get 24.57, but you could just do 0.33 because I'm going to subtract that, and I'm going to get, it takes her about 6.098 minutes longer. So this would just be the 33% times the 18.48. So actually a pretty easy way to solve this problem. Let's see, do they want us to round your answer to the nearest minute? So my answer here is going to be 6 minutes longer. And what I wanted to do, I hope all that makes sense. What I wanted to do for my little extra lesson here, so I'm going to throw this back over here. I just wanted to compare like when there's kind of a weighted amount of something. So if I wanted, and I'll make it real quick, if I wanted to get my average speed across these two data points, you might think to yourself, well, I would just do 50 plus 75 and, or sorry, 50 plus 25 and divide by 2, and you're going to get 37.5. It's very, very much far away from that. And the reason is you have to consider the relative distance they're traveling. This has to be like 95% of your distance, you're going 50. And only 5% of your distance, you're going 25. So our average here should be much closer to 50 than 37.5. So how you would do that for these kind of weighted average problems, if I wanted my average speed across these 2 points, I would have to get a percentage, right? I would say maybe 0.6 over 16, because that's just those 2 added. So this would be a percentage of how much I'm driving 25 miles an hour plus 15.4 over 16 divided by 16 times my 50. So what this is actually going to get me is my actual average speed. So let's just do that real quick just so I can help you guys. 15.4 divided by 16. 15.4 divided by 16 times 50. So I'm going to get about 48.125. And then I get 0.6 divided by 16. Yeah, only 3.75% of my distance times 25, and then plus 48.125. And you can see my average speed is actually 49.0625. So remember, averages and things like that, because I'm trying to set you up for other problems that I've seen, are always going to be relative to how much of the total they are. I don't just do 25 plus 50 divided by 2. I have to do relative to the distance they were driving those speeds. So I hope these problems came in handy. I'm going to hurry up and try to upload my 3rd video before my tutoring session. But yeah,